Welcome to the viewers. Now we discuss the idea of uniform space and further extension, and today we discuss the property of symmetry in uniform space and the diagonal. And these definitions and idea are very much useful to further progress of the study of uniform space in topology. Let's watch. At first we are discussing the concept of diagonal in topology. Let us consider X be a non-empty set. Non-empty set, and so we have X cross X, that is also non-empty, certainly. And now the set of pairs X and X like this, and as X belongs to capital X is said to be diagonal actually this type of pairs, set of pairs and all pairs, actually X is arbitrary, so set of all pairs, all these type of pairs are called diagonal, and sometimes it is denoted by the sign delta, and it is very much useful tools we use few times in this concept for the further betterment of uniform spaces. So we discussed already the property of diagonal in topological spaces and especially in uniform spaces. Actually the parts all such pairs and all such pairs, it should be noted that basic point that all pairs like XX and X belongs to capital X, where this X by X is non-empty and X, obviously X not equals to pi, that's why it is non-empty, and all pairs is known as diagonal. And it is denoted by just delta sign, this type of element, diagonal. Already I discussed this idea. Next we define another property. This property is called symmetric property in uniform space. A subset V of X by X is called symmetric if this V is equals to V inverse. And actually what happens there, if we consider, it should be noted or explanation, if x is equal to the set R of all reals and V is given by that pair of elements, certainly x, y, belongs to R by R region such that mod of x minus y is less than 1, then V inverse is given as and actually what happens there, x minus y, so certainly it will changes its property, and that's why this y and x will changes. And what happens there, then V inverse also, we prove this result, xy belongs to R cross R such that these xy are the pairs that also belongs to V inverse. That means here we consider if xy belongs to H, that means here yx belongs to V inverse. That means yx belongs to V, if we say. And what happens there? And if we consider that yx belongs to V, then certainly we have know that each pair, if xy belongs to V, that satisfy mod of x minus y is less than 1, and yx belongs to V, that is mod of y minus x is less than 1, but mod of y minus x, that will be mod of x minus y, and certainly it will be mod of x minus y, so it is less than 1. We can say it satisfies as mod of y minus x. And if it changes, that means, that is, if xy be the element belonging to V inverse, that also satisfy then we can say V inverse certainly will be xy is belonging to R by 2 real number space, and this xy must be belonging to the V inverse, certainly have. That means if yx belongs to V inverse, we say V, so xy belongs to V inverse, we already assume, and this satisfies these equations since the condition is given mod of x minus y is less than 1. So here we find V inverse xy that satisfies this equation. Mod of y minus x is mod of x minus y, and that is to say, if yx, that is V belonging to V, that imply xy belongs to V inverse. and also we find here xy belongs to V R by R and satisfy this condition. So from these two, this xy belongs to R by 2 R square and xy belongs to V inverse, and here also we find V is equal to this xy belongs to R by R mod of y minus x is less than y, and that is the condition is finally we write V inverse is equal to xy belonging to the element R cross R such that mod of it is also the same property as we find y minus x or x minus y is less than 1 if we conditionally put it here, and that will be equals to also xy belongs to R by R such that mod of x minus y less than 1. So we finally get this result. And also we have V is equal to xy belonging to R by 2 R by R, that is R2 mod of x minus y less than R. So from this two, if we take equation number 1 and if we take equation number 2, from 1 and 2 we have V is equal to V inverse. This is property of symmetry, or this is symmetric. So in this way we idea the symmetric property in uniform space, and this is very much useful into instrument. We end our discussion today. If you like this video, like it, share it, don't forget to subscribe the channel. Thanks for watching.